A program is what makes a computer usable. Without it, even the most powerful computer is just an object. The same way, a piano without a player is just a wooden box. While computers can perform very complex tasks, this ability isn't natural. At their core, computers can only carry out very simple operations, like adding or dividing numbers. However, they can do this incredibly fast and repeat these operations countless times. Let's say you want to calculate your average speed for a long trip. You know the distance and the time, you just need the speed. While a computer can perform this task, it doesn't actually understand what distance, speed, or time means. You must instruct it to accept a number for distance, accept a number for time, divide distance by time, show the result as the average speed. These steps form a basic program. While they're not in a form the computer can directly understand, they can be translated into a language that it can. Language is a bridge. A language is a system used to express and record thoughts. We use various forms daily, like body language or our mother tongue, to communicate and understand the world. Computers use a basic, rigid system called machine language, made up of simple instructions, e.g., divide this number by another. These instructions form the instruction list, IL, unique to each computer model. Unlike human languages, machine languages are man-made and do not evolve on their own. To connect human understanding with computer execution, we use high-level programming languages. These languages are readable by humans and can be translated into machine code. They allow us to write complex instructions efficiently. Programs written in high-level languages are called source code, saved in source files before being translated for the computer to execute. What makes a language? Whether natural or machine-based, every language consists of alphabet, a set of symbols used to form words, e.g., Latin for English, Cyrillic for Russian, kanji for Japanese. Lexis, vocabulary, a list of valid words in the language, e.g., computer, is valid in English, kmoptru is not. Chat exists in both English and French, but means different things. Syntax, rules that determine correct sentence structure, e.g., I am a Python is correct, I a Python am is not. Semantics, rules that define whether a sentence makes logical sense, e.g., I ate a donut is meaningful. A donut ate me is not, unless it's a joke or fiction. Writing a program involves putting together elements of a programming language in a way that causes a specific effect. But it must be correct in these areas. Alphabetically, using a recognized script. Lexically, using valid words of the language. Syntactically, following correct grammar. Semantically, making logical sense. Mistakes in any of these areas can make a program fail. Once you've written a valid source code, you must translate it into machine language so the computer can run it. This translation can be done in two main ways. Compilation. The entire source code is translated once into machine code, e.g., an .exe file. This file can be run without needing the original source code or translator again. The translator used is called a compiler. If you change the source code, you must recompile it. Interpretation. The source code is translated every time it runs. An interpreter reads and executes the code line by line. The interpreter must be present on the end user's computer. You distribute the source code, not the machine code. Most programming languages are either compiled or interpreted, depending on their design. Only a few support both methods. What does an interpreter do? After writing your program as plain text, you use an interpreter to run it. It performs the following steps. Reads the code from top to bottom, left to right. Checks each line for errors. Executes lines that are correct. If an error is found, the interpreter stops and shows an error message. However, the message may not always point to the original cause. For example, using a variable without defining it may cause an error later in the code, not at the source of the mistake. The interpreter follows a read-check-execute cycle, often repeating it many times. Parts of the code may run successfully before an error is encountered. That's normal in interpreted languages. Compilation versus interpretation, which is better? There's no universal answer. Each method has its strengths and weaknesses. That's why both are still widely used today. Advantages: compiled languages, very fast execution, no interpreter needed by the user. Code is protected, not human readable. Interpreted languages, easy to test and run immediately, works across platforms with the same interpreter. Great for beginners and quick development. Disadvantages: compiled languages. Slow to compile, must recompile after each change. Different compilers needed for different systems. Harder to debug. Interpreted languages. Slower execution, runs line by line. Interpreter must be present on every machine. Python is an interpreted language, so it shares all the typical advantages and disadvantages of interpreted languages, along with a few unique traits of its own. To run Python code, you must have a Python interpreter installed. Without it, the code won't execute. Fortunately, Python is free, which is one of its major benefits. Because of its interpreted nature, Python is often called a scripting language, and its programs are known as scripts. Now let's get to know Python.